is Shri Panna Lal Biswas, MD and CEO InPhase Power Technologies. Shri Biswas, an IIT Kanpur alumnus with 30 plus years in power electronics, leads InPhase Power in delivering advanced power quality solutions to metro, rail and heavy industries. Formerly AVP at ABB, he has also contributed to R&D at CPRI and published extensively on power systems. Under his leadership, InPhase has successfully supplied more than 6 lakh AMPS of STATCOM, SVG and AHF solutions, along with hybrid power quality systems to major industrial and infrastructure projects in India. Let's please welcome the final speaker for this session and the day, Shri Panna Lal Biswas.
Ladies and gentlemen, so I'm just quickly reduce the time of my presentation so that everybody can be, in their time if they want to catch the flight and etc. all this. So we are basically, InPhase is in the field of power quality solution. Our main objective, if you see in this, our mission is basically enhancing the power quality. And similar line in that, we wanted to enhance the active compensator in India, ramp up the production, and also we want to expand the complete spectrum of the active compensator and make in India and make for the world. So if you see 90 to 95% of our product is everything based on the power quality and power conversion only. And we have close to about 95 years of experience in the field of power quality. And we are the first to make the 3-level active filter of highest rating 630 ampere. We have delivered more than 6 lakhs ampere all over the world. And we have been also, our R&D has been recognized by DSI, Department of Science and Industrial Research. So there are 3 major problems in the power quality. Like if you see the reactive power, inductive capacity, power factor, which is linked with that. Second is the harmonics. And third is the unbalance. Now, if you see, when you took any whether RSS or you talk about the traction substation, so major, you need the basically active power. But what happened when the motor starts, then it started drawing, taking the reactive power also. So after that, if you have 3-phase loads and if there is not phase, all the phases are current is not equal, then it started drawing the unbalance also. Then if you have the drives and all these things, then also it started drawing the harmonics. So what happened, the transformer for which you have purchased that actually basically to reduce the voltage from let's say 33 kV to 415 or 220 by 25 kV, it is not only drawing the active power, but it also draws the active power, reactive power, unbalanced harmonics, etc. So this active compensator, what it does, it basically cleans all the dirtiness from the power. That means it does the reactive power compensation, then it can do the unbalanced compensation, then it can do the harmonics compensation. So the objective is this, because if you see yesterday's discussion also, that we wanted to increase the freight corridor, double the capacity, and at the same time, we also wanted to do the carbon, zero emission by 2030. So what will happen? You need to have the, an efficient electrification basically. So by doing this, what happened? It is like we use the water filter, we are using the air filter to clean the air. Here we are using the power filter to clean the complete dirtiness in the system. So by using this, you will be able to reduce the current, because some cases where the current earlier was drawing 2300 ampere, same operation is going on, but it is drawing now only 1300 ampere. So by improving these within existing operating line and without any capex and opex much investment, you will be able to transmit more power and you will be able to increase the capacity of the engine. So typical power quality issues for the metro type of applications, where major problem is the 33 kV cable actually, which causing the cable capacitance, and because of that most of the RSS and ASS is loaded with the maximum amount of reactive power. So normal loads usually will have the inductive power. In case of metro, there will all have the capacitive power. And power factor lows as high as 0.3, 0.4, which means the efficiency of the system is hardly like 30%, 40%. When you talk power factor unity means it is 100% efficiency. So we have seen the many places where the electricity bill, 300 to 400% higher as compared to the what energy bill it should be. Because nowadays most of the estates, what is also they are going for the kVH billing. So that means whatever you are drawing along with the transformer, like whether kilowatt, kVA, kVR power, everything is charged at the rate of per unit. So also the CA regulation and IEEE, all these things are there, which guideline is there for harmonics and all. Here if you see metro applications, normally what happen in industry, when the peak time, your load goes high, that time your transformer loading will be maximum. But in case of metro, you see, between 11 o'clock to morning 5 o'clock, the load is maximum. It is in opposite way. That means because of the cable capacitance, the reactive power, due to the capacitive reactive power, the RSS is getting loaded heavily high. So because of that, the power factor is also very much falling down. So they have to pay huge amount of electricity bill. And for such kind of system, if you see that you have the RSS is there, and this RSS we are putting one equipment which is measuring the complete reactive power requirement, and balance it is distributing to all the ASS, means auxiliary station. Every metro station we have the panel. So it is getting the signal, whatever compensation is there, let's say 3,200, 200 is giving by the RSS, and balance 3,000 is distributed to, let's say 10 ASS is there. So 3,000 divided by 10, 300 kVA will distribute by all the ASS. So like this, if you see, each metro will have expansion, RSS1, RSS2, RSS3. So all these things also can be interlinked and they can be upgraded. And also if one of the ASS fails, then automatically it can switch over to RSS2, or RSS2 ASS can feed from RSS1. So all this kind of innovation technology that we have done first time in India, that is with SEEDCO first, and after that same success story is repeated to Pune Metro. After Pune Metro success story, then it is repeated to Nagpur, and many other projects like Bangalore Metro or Chennai Metro, they are all in operation. IRCON. So these are all first time we have implemented. Like this is one of the case where the SEEDCO, you can see the 220 kV feedback is coming, and it is taking care for the entire reactive power compensation. And this is distributed to all the ASS also. So similar thing, it can be done for the centralized compensation. This is for various installation you can see. So this is a very advanced technology, and we also got many appreciation later from the installation that we have done. So this is a typical kind of applications where most of the metros, as infrastructure is growing, so we will have this kind of problem. Similarly, so another important point is that if you want to attack any country, you don't need to put nuclear bomb actually. What they say today, recently I was in IIT Bombay, so one of the power grid director, he was saying that you don't need to apply nuclear bomb, you just cut up the power of that country for 30 minutes, you see that most of the all the IT industries will go away from that. So today what is important, if we more and more digitalize when you are doing, at the same time we should also know that how to protect our technology within the country. So that is why we have to see that more and more indigenously developed in the country, it is well and good actually. And this is also the entire R&D has been designed by India only, and we have supplied, today if you see, we are the only first Indian company indigenously who has developed from 330 volt to up to 33,000 volt. So you have direct connection up to 33,000 volt using active compensator without any transformer. So also this is also, it can go up to from 50 kVR up to 50,000 kVR, means almost 50 MVR. So technology trend in terms of the power quality solution, if you see, earlier traditional technology was capacitor based solution, now it is capacitor is not there because the load itself is capacitive in case of metros if you see. And then the technology is going from automatic APFC till now it is cascaded edge bridge connection. Our load is very dynamic, then over voltage, under voltage, and typical TSS due to the tripping issues are coming, and also sometimes malfunctioning due to the relays and etc. So these kind of problems can be faced by the power quality due to power quality issues in the TSS. So this is basically the hybrid technology, which is the electronics technology. That means the capacitor is replaced with the complete electronics, power electronics, and this can be connected in series number of cells in order to meet the 25 kV system. So railway basically you have two kind of system, one is the single phase, another is three phase. So this power electronics can be kept inside the room, and then it can have water cooling as well as air cooling system and connected through the fiber optics, so that there is a high degree of galvanic isolation is there, and it can go along with both existing capacitor, along with that also at the same time additional also it can be done. So you can see this complete technology is developed in India first time. So you can see every IGBT power module, this can be connected in series to make the complete 33 kV or 25 kV or 11 kV, whatever the railway requirements are there. So this whole thing can be put it also in a container just to keep it outside and for a smooth project execution. So whenever railway requires a lot of time for civil and construction due to rainy season, all you cannot do the project in timely. So if these things can be put it in a container, easy execution, just connect it to there and connect the power cable, CT feedback, and you can commission the system. So we have thought a lot of ways that how these things can be done, and entire thing also has been type tested in India, so that before any product we launch in the market, we first do the type testing. And this is also like RDSO, if you see, they have three-phase connections also there. One is the V connection, V-type connection, another is the main winding and teaser winding. So this complete setup, we have that, depending on the voltage level, like 6.6 kV, 11 kV, 22 kV, 33 kV, like that. So this complete setup is in Bangalore. So we can give you the full support right from the, starting from the design, engineering, supply, commissioning, and even after field support also. So all our own brothers, sisters, they can only do the servicing, no need to get the technology from abroad and depend when they will give the support on the IT. So entire thing has been developed, entire R&D has been in India only. So thank you for all of you. This you can see, we have enough amount of appreciation letter and award. In fact, there was one magazine where we found that, top 5 emerging company, where InPhase has been, recognized from India as a top emerging company. So we got a lot of awards from MSME ministers and all. Also from Professor Pai also. Out of 320 suppliers selected, we got the best award. So thank you very much. For if you have any questions or anything, we can either send it by mail or we can ask. Thank you. Thank you all of you.